Welcome and thank you for joining us. We are presenting a question that was done in KCSE 1992 paper 2 number 23. Question reads, the relationship between the variables x and y is known to be of the form y is equals to k x power n. This is a nonlinear function where k and n are constants. For some fixed values of x and y were obtained experimentally. The corresponding values of log x and log y are given in the table below. We have log x and log y. Draw the graph of log y against log x. Remember, the function given is of the form y is equals to k x power n. This is a nonlinear function, but it has already been reduced into linear. And linear is usually in the form of y is equals to mx plus c. In this case, to convert a nonlinear equation to linear, we introduce logarithms such that we have log of y is equal to the log k x power n. Then we move down and have log y being equal to the log k plus the log of x power n. Remember the rules of logarithms. Then the log y is equal to the log of k plus n log x, and if we reorganize, we are going to have the log of y being equal to n log x plus log k. In this case, n is our gradient and log k is going to be our y-intercept. Since we have been given already the values for log y and log x, we move down and plot our graph. Remember, x has values ranging between 0.3 and 1.3 positive, and we have the values of log y ranging between positive 1.398 and a negative of the same value. So for us to have our graph, we are going to have values of y positives and the negatives at the same time. So we are going to have our graph beginning at this point here, such that we have 1 centimeter representing 0.5 units, then 1.0, then 1.5, then 2.0. Then on the negative side, we are going to have negative 0.5, then negative 1.0, negative 1.5, and probably negative 2.0. Then at this point origin, remember the values of x, remember this is log y. Then we have the log x on the x-axis, but we are going to have the values of x or log x ranging between 0.3 and 1.3. So we are going to begin with 0, then have 0.1. For us to have that range, we are going to have 0, then 0.2, 0.4, 0.6, 0.8. Then we are going to have 1.0, 1.2, 1.4 up to around 1.6. Then once we have all our values captured, we can be able now to go down and plot our graph. Remember, when log x is 0.3, the other one is 0.1398, which is approximately 0.4. So we are going to go to 0.3, which is at the center, or between 0.2 and 0.4. Then we go all the way to 1.3. This is 1, 1.1, 1.2, 1.3 is here. So we have our first value here. Then when it is 0.699, which is the same as 0.7, the other one is 0.6. So 0.7 is between 0.6 and 0.8. So this one is going to be 0.6 at this point here. Then when it is 1, it is 0. When log x is 1, the other one is 0. And when it is 1.3, it is negative 1.398, which is negative 1.4, sorry. So 1.3 is between 1.2 and 1.4. So we move down. We are going to have 1.3, it is going to give us negative 1.4. Negative 1.4 is going to be here. Having gotten all those points, we can now connect them. We can now join all our points like this. And after joining our points, after joining all the 3 points, we can now be able to proceed. We join all these points, tried to connect the 3 points so that we can have the line of the best fit. And once we have our graph drawn like this, we can proceed and answer the questions that have been asked in this case. Remember, from the questions we are supposed to answer, one is where we are supposed to estimate. Where we are supposed to estimate the value of n. Remember, n is the gradient, and therefore to get the gradient, we are going to take the change in y over the change in x. Remember, we can pick the point where we have this triangle like this. Then we join it this way, such that we are going to have the change in y. So the gradient is going to be equal to the change in y over the change in x. And this one is going to give us where this point is here. It's around 1.9, which is roughly, that is 1.95, minus the value of y at the origin is 0, divided by the value of x at this point is 1, minus the value of x at this point, which is origin is 0. This one is going to give us 1.95 divided by 1, which is going to give us 1.95, which is going to be approximately 2, correct to the nearest whole number. Now that we have the value of n, let us get the value of k, and the k is going to be equal to the y-intercept. Remember, we are going to begin by getting the log k, which is going to be our y-intercept, or the point where the line cuts the y-axis, and that point is going to be equal to 1 point around 95 there. So this is going to be around 1.95 or 98 there, which is approximately 2. And in this case, we are now going to get k by getting the antilog of 2. And from the calculator, the antilog of 2 is going to be exactly 100. Those are the 2 values that we are supposed to determine from our graph. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you'll automatically be given a notification. Thank you and welcome.